talk about the code which is used, which I've implemented to train all the models, uh, starting from the data analysis, then feature extraction, then the model training. So the first step in the data analysis was labeling the raw logs. I'll show the code. Okay. So these are all the imports. This script is implemented to label all the logs as normal and as threat. So we'll be talking about the code now. Imports and global configuration are all these. These are all the labels, the raw patterns, and the category. These are all the functions implemented for text normalization and fuzzy match. This function is to load the dataset. Then coming to the embedding and similarity calculation and generation. Then the data statistic functions to get the stats of the data uploaded. I also implemented a smart pattern library to store all the patterns of the logs which are labeled. This pattern library helps in labeling the logs in future, which can be used to make the process fast. Then coming to the template labeling pipeline. This is the complete pipeline for labeling the template. This function are to validate the labeling quality and to analyze the cross-source patterns. Then this function is to combine all the data set and create a separate file for combining all the logs analyzed for a particular source. This is the source manager class. Now we'll be seeing the system, how it is initialized. This is an interactive system which can be used by anyone. Just run the script once and you will be able to label the log manually. You will be seeing all the suggestions below. I can show you an example here. So this is how the labeling works. These are all the data set loaded. And then this is the workflow. To get started, you just run all the cells below, the streamline workflow cell, and start labeling. So like it will, after every iteration, it will update the pattern library. It will train the ML model, and the ML model will be then recommending the next anomaly. Coming to the data processing part. So these are all the imports and initial setup, including the timestamp functions. These functions are used to parse the timestamp because different logs have different timestamps format. So these functions are used for that purpose. This is used for detecting the log type. Now, it involves the loading and processing of all the labeled CSV files. This is the function which combines the process and then at the end, saving all the normalized data set. Now coming to the feature and engineering part. So these are all the imports. For the feature engineering, I used PySpark. So PySpark SQL and Drain3 for the template mining. Now this is the Spark session creation, the project configuration, and then device setup. So now we'll be seeing the temporal and statistic feature extraction, which involves text-based Spark UDFs. These are all the UDFs initialized for Spark. Then Spark feature builder for building all the features and uh, uh, extracting all the features and then again appending them into the database. It involves the creation of imbalance data sets, imbalance features, and statistical features, which would help in the further model training. Now this is the main processing loop, which calls all the functions over all the logs and creates the features at the end. Now this function will save all the features at the particular path. Now we'll be creating cross-source splits, the train time split, which will be used further for the training of the models. Now we'll be looking at the model training pipeline. First, we'll see the ML model creation. In the ML model training, I'm using Joblib for parallel and delayed processing. Parallel processing is important in this pipeline because uh, ML models take too much time or larger data set, and it also don't use GPU. So we have to use parallel processing over CPU to make the process faster. Yeah. So this is all the configuration part. Then coming to the loading of all the features which were saved in the feature engineering pipeline. Then these are all the classes to validate if the data set is loaded correctly. The focal loss weights, then calculating the mean. Then this is the model configuration. These are all the models which I implemented: LR, RF, XG classifier, gradient boosting, SVC, KNN, decision tree, naive bias, and light gradient boost mining. Then this is the bagging and ensemble models. Now this is the training loop, which involved all the parallel processing as well as the model training. This is how the models are trained, and at the end of the training of each model, the summary of is generated for all the models. Here, all the cross-source evaluation summary is generated and saved, and then training the final model on the complete dataset to be used for production. And at the end, generating visualization of the whole training process. As you can see, we get an FN macro performance by source, and then the best model frequency, followed by the matrix distribution across source and performance. The result is generated and saved at a result location. Yeah. Now we'll see the deep learning models. Okay. These are all the imports. Then the configuration part. Here, all the features which were saved earlier are loaded. And this is the dataset class. It includes the focal loss class. Now, here the models are implemented, the model architectures. First one is a class for VAE, then followed by the CNN with multi-head attention, then tabnet, followed by stacked encoder, and then transformer encoder. Now, these are the functions to calculate the class weights and apply SMOT. SMOT is when we create synthetic dataset, and the training epoch. This is the function to evaluate the training process and the matrix calculation function. Now, this is the stored source strategic determination, which is calculated based on the number of epochs, the dataset quality, the imbalance in the dataset for each source, and this is the training loop. Now we'll be seeing the met the BERT models. So These are all the imports and dependencies. Then the setup and the configuration. Okay, this is the loading of the features, which is common for all. Then the bird configuration and the model configuration. Now, this is a function to pre-process the logs. Then the dataset classes. These are the classes and the functions to for the loss function. Then coming to the BERT model architecture, the log BERT architecture is implemented, the domain adapted BERT, then dberta v3 and the npnet. Now these are the functions for data handling, the function to compute file hash, the function to calculate class weights, then the function to get imbalanced tire, function to calculate the geometric mean, IBA, then enhance metrics and class weight sampler ration, then applying smote. Now this is the training function and this is the evaluation function. Then this is the function to fine tune the threshold and the final training function. This is the function to train a single model for split. And then this is the function to create to process a single split. Yeah. This is how the training was done. And at the end of the training, the test results were loaded and saved at the desired file location. Now we'll be talking about the advanced algorithms. First, we'll be seeing the hierarchical transformer. This is the hierarchical transformer, the imports and the configuration part. Then the extraction of templates. Then the normalization of the timestamps. And then the tokenizing. This is the pre-tokenized augmented block dataset class. Then this is the gradient reversal function. Then template aware retention for the extracting the meaning from the templates. This is a temporal module. Then the source module, domain adapter layer. Then this is the main HG log former class, which is hierarchical transformer. It includes the function, the initial function and the forward function and the train function. Now, these are the functions to compute the class weights, the focal loss, consistency loss, com then the final log computation, and then the matrix calculation. And this is the function to train an epoch, an evaluation, and then finding the optimal threshold. Now, this is the function to run all the splits. This is the final call, final loop for training all the 16 splits. This is how all the epochs were done. At the end of the every epoch, I was getting the training loss and train F1 and the F1 balance accuracy and the best model. Each split was trained on 5 epochs. And after the complete training, the results were saved and A final model was trained over the complete dataset for production. Now coming to the federated contrastive. So this is the imports and the configuration part. Then the feature loading, then the template extraction, creating contrastive pairs, and the main class for contrastive pair dataset class. The template aware attention, and this is the main class for the federated contrastive model. Then these are the functions for calculating the loss, contrastive loss, focal loss, and template alignment loss. And then this is the function to train the client and evaluate the client. Then coming to the federated averaging, because for every source, different weight is calculated. So at the end, we have to uh, parse the global model, the client models, and the client weights, and this function will calculate the average for all the models, and then save the save the dictionary there. Then this is the function to calculate the client weights. Now this is the main function to run the federated round for each and every split, and then preparation of the client, and then evaluation. This function will run the pipeline over all the sources. Then coming to the final call and the final loop, and then saving the best model for production. Now we'll be talking about the meta learning. So this is the meta learning code. This is all the imports and configuration, the device setup, and the feature extraction, followed by the metrics calculation, then creation of few short episodes, creating balanced and imbalanced episodes. Then these are the loss function, the prototypical loss, focal loss, and the contrastive loss, and then combined meta loss. Coming to the classes, this is the episode cache class, then the function to support set augmentation. Then these are the adaptive inner steps which occur in the meta learning pipeline. Then the residual block, attention pooling, and the meta network. This is the final loop, the inner loop of the meta learning, and this is the batched inner loop. Then this is the function to process a single task. Then these functions are to process the prototypes and the refined prototype. The configuration is here optimized, and then improved the meta learning for our data set, followed by the training of the sources over all the splits. This is how the training was done over 13 sources. This is the evaluation loop to evaluate the training process. And this is the curriculum loop where all the uh, training and the curriculum phase is implemented with 1,000 iterations. Then this is the evaluation of all the test sources. This is the result of the evaluation, and it is saved at this location. Coming to the the evaluation of prototypical results, and then followed by the transfer results. All the results were saved in the result directory here. Let's briefly see the results directory. The model training is completed. After the model training, all the results will be saved here for each machine learning, deep learning, then BERT results, then uh, hierarchical log transformer, federated learning with contrastive learning, and then the meta learning. After the model saving and the model training, all the models will be called in the backend where in the app folder where I used Django to call all the APIs and use the architecture of the models and create a final API. So this is the code. Yeah, these are the codes for the DL models, the ML models, the all the models, the orchestrator, all the implementation is done here, and the APIs are created in this folder. After that, all these APIs are called in the front end, in the pages, and in the different pages. And as you can see, the log analyzer calls all the APIs and uses them to predict the anomaly. The hosting was done on Vercel. The front end was hosted on Vercel, the backend on Render, and all the models were stored in the Hugging Face hub. So, thank you for watching my demonstration.